So 7.3 in our book deals with formulas involving polygons. So as you can tell from the title, we're going to be dealing with some formulas, and we're going to actually have some slight definitions and names for different polygons that you may or may not have seen before. So let's take a look. Well, polygons, as we've talked about in the past, it has to be a plane figure with the following properties: at least 3 sides, completely enclosed, and made up of only segments. So we don't want any curves, we don't want any openings in our polygon. Naming polygons. Some you've definitely seen before, like a triangle, quadrilateral, pentagon, hexagon. For 7 sides, you'll see heptagon, or sometimes you'll see septagon, octagon, nonagon for 9, decagon for 10, dodecagon for 12, pentadecagon for 15, and anything else like 11, it would just be 11gon, 13, 13gon, 100 sides, 100gon. So there's not clever names for everything, but those that do have a particular name, I will expect you to know. Okay. So our first formula is for the sum of interior angles. If we know how many sides a polygon has, we can always find out the sum of the interior angles, and we have a formula. It is n minus 2 times 180, and that n represents the number of sides of the polygon. So let's take a look. So here I have a 1, 2, 3, 4, 5, 6-sided, so I know that's a hexagon. The reason it is n minus 2 times 180 is because I can draw n minus 2 triangles. So I had 6 sides. I can draw 1, 2, 3, 4 triangles. So 4 times 180 will give me my internal sum, because in a triangle, all of the angles add up to 180. So for each additional side I might add to my figure, I'll be adding one more triangle. I'll be adding 180 degrees. Some of the exterior angles, even easier to figure out. It will always, always, always be 360. It does not matter how many sides the polygon has. It can be 100 sides, it can be 3 sides. The sum of the exterior angles will always be 360. And then last important formula is our number of diagonals. And remember, a diagonal is a segment that connects non-consecutive vertices. So I have myself 2 polygons here. Let's see if it works. So first off, I have a 1, 2, 3, 4, 5-sided polygon. So let's go off the formula, see how many diagonals I should be able to draw. So I have 5 times 5 minus 3 all over 2. 5 minus 3 we know is 2, so I have 10 over 2, which is 5. I should be able to draw 5 diagonals. So let's start off with this top vertex first. So I have 1, 2, 3, 4, 5. And if I look at all my vertices, I have drawn every diagonal I can from each of them. So in this case, in my pentagon, I have a star on the inside, which has another pentagon on the inside, and that process can keep going. But let's look at the other polygon, see what kind of polygon we have, and see how many diagonals we could draw with it, with our formula, and then by drawing it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, making that a decagon. So let's look at our formula. So we have 10 times 10 minus 3 all over 2. 10 minus 3 is 7. So I have 70 divided by 2, which is 35. Now I'll draw the first few, then I'll pause it, and then I'll show you with all the diagonals in there. But clearly, having the formula is a pretty big shortcut, because A, you don't have to draw 35 diagonals or more, and B, in case you lose count, you've got the answer already. So let's get started. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then, for the sake of your sanity, I'll just pause it, draw on the rest, and then at this point you can also draw the rest in yours. So count right now is 20. I'll be drawing 15 more lines, and I'll see you soon. Alright, so I'm back. I finished drawing the last 15 diagonals, and as you can see, it gets pretty jumbled pretty quickly. Again, if you lost count, it'd be kind of a bummer if you had to start all over. If you really wish to count my 35, I was counting as I went, but go for it. There are 35 there. If you did have to draw 35, or say you had a pentadecagon, you need to draw even more, the larger your shape is, the easier it'll be to draw all of your diagonals. But typically you won't be asked to draw them. You'll usually just be asked, hey, how many diagonals can we draw on this figure? And with that we have our formula. So, a couple formulas to know, a couple shapes and the number of sides we need to know, and from there we can solve a lot more problems, which we'll do in class. So I'll see you then.